Hi friends, welcome to my video lecture series. In my today's topic, we are going to discuss how to solve the system of equations, system of simultaneous equations. So there are two methods we are having. One is direct method, another one is iterative method. In direct method, we have Gauss elimination, and in iterative method, we have two concepts. In two ways, we are going to get the solution for that. That will be Gauss-Jacobi and Gauss-Seidel methods. Right. So there are n number of applications we are having for system of simultaneous equations. Here I have given in engineering field, computer science and everything. Additionally, I have given some applications also in electrical engineering, circuit analysis and signal processing. So plays a vital role there. And in structural engineering, these are all the concepts we have. And in mechanical system, computer graphics and robotics, it plays a vital role in 3D transformation and robot kinematics. And then chemical engineering, physics, and so even in astronomy also. Astronomy, computer science and machine learning. And while you're finding, if you want to discuss about optimization problems, it plays a vital role there in operation research and even in game theory also. So now, system of simultaneous equations, as I told you already, we can solve this in two ways. One is direct method, as I told you already. In direct method, we have Gauss elimination method. Iterative methods, iterative method also the next one. We have two methods in your syllabus. One is Gauss-Jacobi, another one is Gauss-Seidel. So these two are iterative methods, and this will be what? Direct method. So in my today's lecture, we are going to discuss the direct method concept, particularly Gauss elimination method. Using Gauss elimination method, how to find the solution for the system of simultaneous equation. That is what we are going to discuss now. Consider the system of simultaneous equations. Here I have considered for three unknowns: a11x plus a12x2 plus a13x3 equivalent to b1. Similarly, three systems are there. Here you know very well aij and ba are unknowns, sorry, are known constraints, and xij are unknowns. Now this system of equation can be written as this one. The coefficients including, if you are writing, it will be a, and the variables x1 and x2 x3, it will be a column vector x, and the constant element b1 b2 b3 will be capital B. So look at that, ax is equivalent to b. In that way we can write here a is this, x is this column vector, and the b is the constant values b1 b2 b3. It's appearing in the right hand side of the system of simultaneous equation. Now what is the concept we are going to follow in Gauss elimination? First we have to form augmented matrix. Augmented matrix, it's a new name you will hear now. It is nothing but augment. Simply, if you want to say a matrix is A, only we will represent A with the B also. In a single matrix, if you are writing together A and B, it is going to call augmented matrix. So now our aim is to reduce the augmented matrix, this augmented matrix, to the upper triangular matrix using row reduction we are following here. Using row reduction, we are going to reduce this upper triangle. How to say it is? This is 3 by 3. This is only matrix, and this one is a B matrix. B1, B2, B3. Together, if you are writing A and B, is going to call augmented matrix. Now our aim is to diminish or reduce this into upper triangular matrix. What will be upper triangular matrix? Here, just listen. I am marking. This three element below the main diagonal element. So this is main diagonal. Below the main diagonal elements, we have to reduce to 0. That one is going to call it as upper triangular matrix. Below the main diagonal elements are zeros, or above the diagonal elements are non-zeros. This is going to call upper triangular matrix using row reduction particularly. Right. So I have to make this step by step we have to do. First, we have to reduce the first column element into 0. In the second step, we have to reduce the second column element into 0. If you are reducing the first column element to 0, we have to use the help or need the help of first row. If you want to reduce second column element to 0, you should use a second row element. Second row element. This is the important thing you have to keep in your mind. So if you know this concept, thereafter there is nothing here. So reducing the first column element, this and this, we have to use with the help of first row element, that is this element. If suppose if you want to reduce this element A32 into 0, we have to use the second row element, second position. This will be we will discuss in detail in the upcoming slides, right? So first one, to do that, they will talk about the pivotal element. Pivotal element is nothing but this. We have, as I told you already, to reduce the first column element to 0, we have to use the first row. While you are using the first row, this element should not be 0. It should be 1. If it is other than 1 also, easily we can solve. I will tell you how to solve uh, in the upcoming slides. So that should not be 0. That element only going to call a pivotal element. Then our aim is to reduce this element to 0. So for that, what I will do, I will multiply A21 by this, A11 by this, and if I'm subtracting both, I can get the answer. Similarly, A31 by this, A21 by this, if I'm subtracting, easily I can get the answer. Then no need to divide by that element. So simply you can do like that. In some other methods only, we have to reduce that element to unity. Cause Jordan, that method, it's not in your syllabus now, so no need to bother about that. 1, 1, 1. So you have to reduce the diagonal element to 1. That one only we have to change the pivotal element to 1. Here it's no need. Without that also, we can easily reduce the column element. I mean, we can reduce it into upper triangular matrix. Okay, that procedure only I have given here. So we have to multiply the row A21 by A11. Then the element will be cancelled. Then subtracted, we can get the that element will reduce to 0. Similarly, try to do for row 3. Row 3, we can get the answer. I will explain with an example. Easily you can understand the concept. So first step is over. We reduced the first two columns to 0. Now what I have to do? This should be pivotal. Pivotal element means what? It should not be 0. It should be 1. Then only we can do. So if you want to reduce this column element to 0, second column element, first column element already we reduced. This is diagonal element. First column element already 0. Now we have to reduce this into 0. For that, we have to use second column element. If you want to reduce, you have to use second row. With the help of second row only you have to do. For that, it should not be 0. That one only I have mentioned here. E22 should not be 0. To reduce that, we have to multiply by that, and row 3 automatically it will reduce to, yeah. Now look at that. This is the upper triangular matrix. Now we have to solve with the help of back substitution. You know very well, this is element x1, x2, x3 constant. So write the equation, and back substitution is nothing but from the last element, we will get the last element, z x3 here. Substitute x3 value here, we can get x2 here. This method is going to call back substitution method. This concept only we are going to follow here. So I will tell you how it's going to work in the upcoming slides, right? I have taken one example for the better understanding. Solve the system of equation by Gauss elimination method. So as I told you already, Gauss elimination method is the direct method. Iterative methods are Gauss, Jacobi, and Gauss Seidel. This is direct method. Okay, right. So these are all the three system of equation. Then how can I write it? So Ax equal to B. I can write like that. A X equivalent to B. This is my matrix A. This is my matrix X is equivalent to B. Now our aim is to take this and this together. We have to write A and B. We have to form a augmented matrix and we have to reduce to upper triangular using row reduction. Then we can get the answer for that. Right. That one only I'm going to do now. So now I'm writing the augmented matrix. What is the augmented matrix? Together A and B. So look at that. I have given separate one line. This line represents this is matrix A. This is matrix B. To identify the difference between them, I have given that line or dotted line we can give here. Then only easily you can identify the diagonal elements. Am I right? If the line is not there, you'll get the confusion. So for our convenience, we are giving that line. So no need to confuse here. Right. What is our aim now? Our aim is to reduce the augmented matrix to a upper triangular matrix. How to do that? So that is what are the what are the below diagonal elements? We are having 2, 3, -1. So these elements only we are going to reduce to 0. We have to do this in 2 steps. First step, we have to reduce the first column element. To reduce the first column element, we have to use the help or need the help from first row. If you want to reduce the second column element to 0, we need the help from, or we have to use the second row elements, second row. This is the important thing. Suppose if it is 4 by 4 matrix, even a third column element, if you want to reduce, it won't happen here. If you want to solve 4 by 4, I will give you one example in future. Third column element, if you want to reduce 0, you have to make the use of third row elements. That's it. This is the simple logic. Now my aim is to reduce the first column element to 0. So how can row reduction I have to use? So this is what the entire row. This element 2 I have to reduce to 0. How can I write? My R2 is what? 2, 3, 3, 10. How can I reduce this element to 0? Which we have to multiply by what? Yeah, using row 1. First call element 0 if you want to do, you have to use row 1. So 2 into R1 is equivalent to 2, 4. It will be 1 into 2, 2. And then it will be what? 3 into 2, 6. So multiply this by 2. 2 into R1, row 1, 2, 4, 2, 6. So now we have to subtract it. Subtraction means what? Here minus symbol, here minus symbol, here minus symbol. This also minus. So what will happen? It will be 0. And here it will be -1. Here it will be 1. Here it will be 10 minus 6. It will be 4. So 0, 1, -1, 0, -1, 1, 4. So this element is going to reduce to 0. Now you have to reduce the second column, this one, next element, 3 to 0. How to do that? Write R3 value and now we have to, in R3 we are having 3. So we have to reduce that to 3. We have to add or subtract. That one only we can do here. That is what the concept of row direction. So multiply uh, R1 by 3 and subtract it. Do the subtraction. You can get the answer. So that one only I have given here. Look at that. My aim is to reduce the matrix, augmented matrix into upper triangular one. Now my aim is to reduce the first column element to 0. That one only I discussed already. That is this 2 element. For that, which one I need? First column element. If you want to replace it, you have to go move with first row. Right. For that, already, as I told you already, the explanation R2 tends to R2 minus 2 into R1. R3 tends to, yeah, or here you can write separately, or here itself you can write. R2 tends to R2 minus 2 into R1. Similarly, R3 tends to R3 minus 3 into R1. Do not do directly, just to do the in which way I explained in the previous slide. That is, so here also if you want I will explain. R3 is nothing but what is in the previous matrix. It will be here I explained. Am I right? Yeah, this is. In this way only you have to do the concept. Do write it separately and then try to write the value here. Look at that, 0 minus 1, 1, 4. What about R3 value? 3 minus 1, and then what? 2. 3 minus 1, 2, 13. So 3 into R1, it will be 3, 6, 3, 9. So we have to subtract now. Subtract both. If you're subtracting both, we can get that answer, what we are getting here. Look at that. That's it. Clear? So subtract both, write the values here, and then R3 tends to R3 minus 3 into R1. Subtract here. Now what is our aim? We have to reduce the second column element into 0. This is 7. We have to reduce this 7 into 0. So how to do that? Any idea, guys? So what are the elements we are having there? Now, what is the explanation I have to write? To reduce the second column, second column element. This is the second column element. Second column element to 0. We have to use second row. So I will explain how it will be. Now we have to reduce this into 0. So if it is 1 or not, other than 1 also no issues. Directly you can multiply by both and you can subtract it. So now I will tell you how to do that. Just listen. What will be the reason? My aim is to reduce the minus 7 into 0. What is the explanation I can write? R3 tends to R3 minus, what will be? Here minus 7 is there. I have to multiply by this 7 and then I have to subtract it again. Then only minus into minus plus 7 into R2. That is the important thing. Previously in the first step we solved for R1. Second step it will be R2. Now what is our R3? R3 is minus 7, sorry, 0, minus 7, minus 1, 4. Minus 7 into R2 is, so multiply this by minus 7, this value. So 0 minus 7, already minus is there, so it will be plus 7, and then multiply by minus 7, and then minus 28. Clear? So R3 minus 7 into R2, or multiply this by 7, multiply this by 7 and subtract both. So what we'll get, already this is 0. Guys, one important thing I would like to mention here. That's why we are getting, look at that. This is the only reason we are choosing the second row element here, second row here. Because if you are choosing first row, what will happen? Here I will get the element 1. So it is absolutely wrong. Am I right? This is absolutely wrong. That's why I'm choosing what? Second row element. Clear? Right. So it will be multiply R2 by 7 and subtract both. If you're subtracting now, it will be 0. Again, here it will be minus 8. Here it will be minus 24. Clear? I hope you have understand now. I think so. R3 minus 7 into R2, or R3 multiply R2 by 7 and subtract both. That's what the meaning. R3 7 R2 subtract both. That's what the meaning. So we can get this answer. This one only I am going to write in that place. This will happen in the upcoming slide. So that reason I have written. Look at that. 0 0 minus 8 24. What is back substitution? You know very well, this is x, y, z. This is constant. X, y, z constant. X, y, z. This is x, y, z constant. In that way we have to write. Then only we can get the answer. That concept is going to call back substitution. But what is back substitution? From the last row, we are going to find z. Apply that z value here, we can get y. Apply z and y here, we can get x. That's what the thing here is going to happen. Look at that. From the last row I have written minus 8 is z equivalent to minus 24. Then what about z value? Minus 3. Using that, write the second row minus y plus z equivalent to minus 4. This is the concept in second row. Apply z equal to 3 here. Then you can get y equal to minus 1. Similarly, first row will be x plus 2y plus z equal to 3. Substitute the value y by minus 1, what you found, and z by 3 here. Then x value will be 1. So therefore, x equal to 1, y equal to minus 1, z equal to 3. So here you can do the cross check. Sir, how to do the cross check? I will tell you now. What is our equation here? The original system of equation. It is there. It will be. It's in the first slide. I will show you. Yeah, this will be the original system of equation. Take your calculator. Press mode button 3 or 4 times. There will be equation mode. It will ask 2 unknowns or 3 unknowns. 3 unknowns. You have to give for 3 unknowns. It will be. If you are giving 3 unknowns, it will ask. Most of you will know how to solve the system of equation. 3 unknowns. 3 equations for 3 unknowns. Give the values. Coefficient of x. First equation a1, a1, a2, a3. Sorry, a1, b1, c1, d1, and a2, b2, c2, d2. A3, B3, C3, D3. You have to insert all the values in your calculator. That and the coefficient of x, y, z in the first equation, second equation, third equation. The value, constant value should be in the right hand side. If you press equal to button, you can get the answer x value, y value, z value, what you obtained already. This is the way to do the cross check whether your answer is right or wrong. I hope you have understand now. Thank you guys. Thank you for watching. We will meet in my next video. Thank you.